Geometry Section 10.5 Tangents. A tangent line intersects a circle in exactly one point. That point is called the point of tangency. The first theorem says a line is tangent to a circle if and only if it is perpendicular to the radius drawn to the point of tangency. So here's the radius, the point of tangency, and that forms a perpendicular angle. Example 1. RS is tangent to circle Q at point R. Find Y. Okay, QR is a radius, and they tell us that RS is tangent to the circle at point R. So that means QR is perpendicular to SR. So what we're working with is a little right triangle. So we'll pull that over to the side and use the Pythagorean theorem to find the missing part. Leg squared plus leg squared equals hypotenuse squared. So QR squared equals 20 squared minus 16 squared. QR squared equals 144. Take the square root of both sides. QR equals 12. But that's not the answer to the question. The question says find Y. So Y is 2 times QR, and that equals 24. The next theorem says if two line segments drawn from one exterior point are tangent to a circle, then the segments are congruent. So here's our circle R and our point that's an exterior point. So AP is tangent to the circle, BP is tangent to the circle, and so these two line segments are the same length. Example 2. Find X. Assume that segments that appear tangent to circles are tangent. Okay, we know that FD is the same length as ED because of the theorem we just read. They're two tangents from the same exterior point. So because of that, FD is Y, ED is 10, so Y equals 10. So then we'll replace Y with 10 throughout the problem. So GE becomes 10 minus 5, which is 5, and FD is 10. Now we can look at the two longer tangents. GD is also the same size as HD because they're two tangents drawn from an exterior point. The length of GD is 5 plus 10. HD is X plus 4 plus 10. So that simplifies to 15 equals X plus 14. Subtract 14 from both sides and you get X equals 1. If a polygon is circumscribed about a circle, then each side of the polygon is tangent to the circle. So this red triangle, triangle TRS, is circumscribed about this circle in the middle, and the points A, B, and C are points of tangency. Okay, and the final example, triangle HJK is circumscribed about circle G. Find the perimeter of triangle HJK if NK is equal to JL plus 9. Okay, so first we'll look at just this little section here. LH is 12. But LH is also a tangent to the circle, and so is HN. So two tangents drawn from the same exterior point are congruent. So that means LH is 12, and so HN is 12. By the same token, JM and JL are the same length. So if JM is 18, then JL is 18. So now we know that JL is 18. They told us that NK equals JL plus 9. So replace JL with 18. NK equals 27. So NK is 27, but that also means then that MK is 27. And now we're ready to finish the problem. The perimeter, we'll just add up all the different parts, and we get that the perimeter equals 114.